Okay. Good afternoon, folks. It looks like, despite whatever issues are going on with Zoom, that most folks are able to get in. So I am going to go ahead and begin class. This, of course, is Calc 1. My name is Professor Filesticker, or you can call me Professor P or John, whatever you're comfy with. Today, we're going to do a handful of things. I'm going to get my doc cam set up here for you guys, and then I'll show you how this is going to go. All right. So most of the time when we are in class, you will see this, which is a document camera. And a good rule of thumb is everything I write here, you should write in your notes, right? Think of this as like the board in class. So this, of course, is MAC2311, section 004, lecture on 8/24/20. And today, we're going to do a few things. Of course, we're going to go over the syllabus. We'll talk about WebAssign, homework. We're going to talk about the textbook a little bit, and we're going to talk about some office hours. And then after all that's done, we'll talk a little bit about functions, real numbers, limits, kind of all these intro topics from chapter 2. So this is like 2.1 and 2.2. Intro to sections 2.1 and 2.2. Oh. So 0th, I want to go through the syllabus with you guys and make sure we all have an understanding of what's expected and what's required. The syllabus is like a contract for how the class is going to go. So let's do that. If you haven't seen it yet, the way to get to our syllabus, you go to our Canvas course and you can click on the home. The home page here is also the syllabus page. But this is not the full syllabus, right? This is kind of just a little blurb. It's just the most important basic things from the syllabus. So the full syllabus, to look at the entire document, you need to click this link, the one that says click here to access the full syllabus. It includes class key to register for WebAssign. So let's go ahead and download this document. You should be prompted whether or not you want to view it in the browser or save it on your computer. If your browser is set up as your default PDF viewer, then it'll probably just open. I want you to do me a favor. Either way, I want you to make sure you save this on your computer. So don't just look at it in the browser. If it opened right away, please find the File Save option or just hit Control-S. And then somewhere in your computer, somewhere where you often store things, like for me, I have it on my desktop. I recommend having a folder for this semester, and then within there having a folder for this class. Because we'll have a lot of documents that you need to save, store, send, stuff like that. So you can go ahead and save the syllabus in there. And then once that's downloaded, oh no, I don't want you to open in the browser. Once that's downloaded, we can open it up. PDF viewers, I will be sending you PDF files often. You will be creating PDF files from time to time. So I do not recommend having your default application for PDFs being the web browser. I strongly encourage you to use Adobe, or my favorite is this one. It's called Sumatra PDF. It's really nice, it's really simple, it's really lightweight, so it works well on mobile devices, works well on everything, and it doesn't clutter up with a bunch of crap like Adobe does. Browsers just tend to not render PDFs quite correctly. So If you are here, then you know that this is Calc 1. Hopefully we all know it's fall 2020. And the section number for this course is 004. That'll be important in a few different places, so make note of that. My name is John Filesticker. I'm an assistant professor here, which means I'm not tenured yet, but I've been with Santa Fe for about 4 years. Before that, I taught at UF, before that at UCF in Orlando. You can call me John, you can call me Professor, you can call me whatever you want. If you're worried about pronouncing my last name, it's like Filesticker. So pretend the P isn't there, but don't stress, either way, I don't really care. My office, my physical office on campus is the Northwest, that's the main campus, and it's A031D, that's downstairs on the north side of building A. And if we're able to do in-person office hours later in the semester, that's where I would have them. But right now, we're not able to do any. Email is the best way to get a hold of me. Email or Canvas messages. If you send me a Canvas message, that'll automatically get forwarded to my email. Those are definitely the best way to reach out to me. You can call this number. I do have this set up to forward to my cell phone right now. So if you call that number, my phone will ring. But don't bother leaving voicemails here because I can't check those remotely. I have to be there in person to check the voicemail. So if you call this number and I don't answer, just go ahead and send me an email or a Canvas message. Class meetings, definitely, we all got that figured out because we're all here. They'll always be in the same place. It'll be an announcement on Canvas with a link to a meeting, and the links will change. They will not be a standing link. There's a few security reasons why I don't want to have a standing link. Office hours are one of the things we're going to talk about today. I'll go into some detail about when those are going to be. But basically, there will be 2 systems for office hours. I'll have 4 or 5 scheduled standing office hours, and there will be a link to those here. So after I've got them all set up, there will be a link right here on our Canvas page. If you go during any of the times we decide on and click that link, you'll be taken to a Zoom meeting and I'll be there waiting to answer questions. Or if you want to meet sometime other than those scheduled times, you can always send me an email or Canvas message requesting an office hour. And I expect to do 4 or 5 of those per week also. So don't be shy. You're not like asking for a favor. It's very much a part of my job to do those appointment office hours. So you don't need to hesitate at all. If you ever want to meet and the regular office hour is inconvenient, just go ahead and send me a message and we'll schedule one outside of those times. It's not a big deal. Happy to do it. I would, in your phone calendar or whatever calendar you pay attention to, but I know these days, usually the phone, go ahead and put this in. It's not our normal meeting time. I think the 7th is a Monday, so it is one of our normal meeting days, but it's not our normal time. So your final exam is December 7th at December 7th, 2020 at 1 p.m. And it's a 2-hour test, so it'll go from 1 to 3. So this is Calc 1, so the prereq is getting through either a pre-calc and trig or the combined trig pre-calc class. The textbook we're going to use is Stewart. Stewart is an ancient book. It's been around forever and ever. They're on the 8th edition now. And we use the early transcendentals version. That's important. So transcendentals, what they mean, they're talking about what are called transcendental functions, like the natural log and sine and cosine. All of those sort of special functions, they're called transcendental functions. So early transcendentals means that they deal with those functions early on in the book. And that's what we use, so you want to make sure you get that. The ISBN 13 is right here if you want to search by ISBN. I do have a PDF of the textbook here. If you want a hard copy of the book, I can help you hunt down a cheap hard copy. There are resources like abebooks.com where you can get international versions and used versions pretty cheap. If you want a PDF of the textbook, I did not pay for this one. I found it years ago somewhere online, and I can help you hunt one down also. So I'm a big fan of the PDF. If you would like that, please reach out to me. Again, Canvas message is the best way. But you will also get access to the textbook through WebAssign. So that's the next thing we wanted to hit in the syllabus here. Since you guys right now, that's Calc 2. That's Calc 2. Let's just keep yours open. Right. So the next thing we need to hit here is WebAssign, and WebAssign will have an electronic copy of the book you can use also. So in case you haven't used WebAssign before, you can go to our Canvas page here and click this link that says click here to access WebAssign for online homework. And then you can click here to enter a class key. the class key you want to enter is this. If you already have an account, you can link an old WebAssign account to the new class key. If you purchased a multi-semester access, you can log in to your existing account and then add a new class by entering a class key. If you have any trouble getting signed into WebAssign, please reach out to their support people and also reach out to me, because sometimes I can lean on their support people and get them to be a little bit more responsive. You will need to buy an access code for WebAssign, and the WebAssign access code is kind of what takes the place of the normal textbook costs for this class. WebAssign does have an ebook that you can use. It's similar to the PDF I have there, except it's got like embedded videos and stuff. The access codes are around $100, sometimes a little less, sometimes a little more, depending on where you get them. And you don't need the access code right away. So if you don't have the access code, you can still register for our class using that class key, going through the procedure I was just showing you a second ago. And when you get to the place where they ask you for the access code, look down on the bottom of the page for an option that says like use temporary access or something like that, trial period or whatever. That trial period or temporary access will last 2 weeks. And then at the end of the 2-week trial period, you'll get kicked out unless you've purchased an access code and input that. So either way, whether you have an access code or not, please use this class key to sign up in WebAssign today. And then as soon as you can, grab one of those access codes and make sure you're all squared up with WebAssign so they don't kick you out. If you get kicked out, it's a bit of a pain in the ass to get you back in. It's very doable, but it usually means you like lose a day or two where you're actually able to work in there, and that can cause you to fall behind. So really the way to go is to get that stuff squared away before it becomes a problem. Calculators. So the way I structure this class, you shouldn't ever need a calculator, but I know a lot of people feel more comfy with calculators. And then of course the online homework has a slightly random component to it sometimes, where it'll generate random numbers here or there. So sometimes the arithmetic can get a little bit out of hand, and you're welcome to use the TI-32XS. That's the calculator that the department has decided is kosher. You're welcome to use that on the tests, on the homework, wherever. But graphing calculators and calculators like the TI Inspire that are capable of symbolic manipulation, those are definitely not allowed. In the homework, if you want to play around with graphing utilities, that's great. I encourage it. I'll post Desmos stuff for you guys to play with all the time. Those things can be nice, but you want to make sure you're to a place where you can solve the problems without using any of that. In particular, your graphing skills need to be very strong. Okay, office hour. Where are we to office hours yet? Oh, am I? Yeah, okay. Oh yeah, so you'll need a computer. Of course, everybody here has some sort of computing device that they're on. You'll need consistent internet access and a functioning webcam. You're not required to have your video feed on during class. Of course, it's nice. I can see your faces and follow how you're reacting to the material, but especially for the exams. So the exams in this class are going to be proctored using HonorLock, and they require you to have a reasonable quality webcam so you can get a good high-res photo of your ID and do a room scan, all that stuff. I think that's it. The office hours, we'll come back to this after we finish going through the syllabus, and I'll show you what we've got so far. So course description, this is the first of 3 calculus classes, Calc 1, Calc 2, Calc 3, and this one, we focus on really understanding the real numbers. The real number line is a strange place, stranger than you may think. And we're going to talk about limits of functions. We're going to talk about what it means for a function to be continuous. Rather than having the kind of intuitive idea from algebra, we're going to have a very strict definition. We'll talk about rates of change, slopes, and that leads to the discussion of the derivative. And then from there, we'll develop a bunch of techniques and tools for solving some pretty tricky problems, like finding minima, finding maxima, getting really nice graphs by using rate of change information. You can look at the full list of the topics for the class by clicking that cyan link. Come here and check it out. This is more for an in-person class type thing, but just be polite, don't use tech in a way that distracts anybody else. And of course, no phones or other smart devices are allowed during the exams. Absolutely not. Attendance, so I'm going to be using Zoom to take attendance. You don't have to worry about typing anything in the chat or saying here, because I've got it set up to automatically record. I do ask that you use your actual name for your Zoom name, though. That way, when I go to look through my role in Zoom, it'll match up with the names that I need to put into the attendance stuff at Santa Fe. Of course, for financial aid purposes, it's very important that I take attendance through the first 2 weeks. And then after that, I'll keep an occasional record. So if anybody ever asks, did this person come on this day, I can give them a roundabout answer. Oh, they stopped coming in this week. Or they showed up every time I took attendance. But it's not a part of the grade. So if you miss a class, you don't need to worry about coming up with an excuse or explaining it or anything like that. Don't stress. Will not affect the grade at all. But you don't want to miss class. Class is important. You want to come to every lecture. Even though the videos will be posted to YouTube, you won't have the opportunity to ask questions and to be involved in the discussion. It's just not the same. So you are required to attend. Makeup policy. I'm usually pretty loose about this stuff. If you are late on a homework or a study guide, let me know why and I'll work with you. Homeworks I have no problem extending. I always extend those. You just submit an extension request in WebAssign and I'll grant it every time. If you miss a test, if you know you're going to miss a test, let me know ahead of time. If you miss a test for some unexpected reason, let me know as soon as possible. I'm not the sort of person who's going to be like, oh, I don't believe your excuse, so you can't take the makeup. You just have to schedule the makeup right away. Makeup has to be done within a week. And you want to be aware that the makeup test is usually a little bit harder than the original. So that's an incentive to not try and bullshit. That's the idea. But yeah, fairly loose about makeups. Just communicate with me and I'll work with you. Homework and study guide. So this is where the majority of your time is going to be spent, especially on the homework. So every week I'm going to release a homework set on WebAssign, 1 set per week. Today I'm going to be opening up homework 1, and that will be due at Monday, start of class next week. All right, so I open the homework on Monday of a given week. You have all week to work on it, and then it's due at the start of class Monday the following week. You expect to spend about 3 hours on each homework set. That's a fair rule. Each homework set is about 3 hours worth of problems. And then about a week before each midterm exam, I will release a study guide. That'll be somewhere between 10 and 15 really good problems. And those will also be on WebAssign. So you'll get the problems from WebAssign and you'll complete them there. But as you solve the problems, you need to write out nice, neat solutions. That's the idea. So as you solve the study guide problems, you're going to pretend like they're test problems and you're going to write out and show all of your work. And the intent is that you should share that work with other people, including myself, either in office hours or by taking pictures and sending it to me in an email or in person with whoever you have in your life that you'd like to share that stuff with. But especially make sure you talk to me a little bit about some of the problems, at least before the test. That way I can tell you these are the things that are good, these are the things that I would take points off of if this was a test. So pretend like your study guide solutions are test solutions. And that way when we talk about them, I can give you a feel for my grading criterion and the expectations I have for neatness, notation, legibility. And you can give me a little bit of an idea of your style. So I'll be able to anticipate things and understand if there is anything weird on your test, exactly what you were thinking, why you were writing that way. So the study guides, make sure to work on them early. Start working on the study guides as soon as they come out, and then talk to me about them. Show me a little bit of your work, and I'll show you a little bit of how I would criticize that work, and we can come to an understanding before the test. That way you're not surprised by anything on the test. Lab meetings. I'm trying to figure out a nice way to do labs here in the online setting. In the past, since the COVID stuff started, I'd just give them as projects and people can work on them in their own time. If I'm able to get things where I would like them, then we would have problem solving sessions. Think of it as a recitation where you guys would present solutions to problems and you can earn bonus points on the upcoming midterms by doing so. But I haven't found a nice way to do that in the online setting. So for now, don't stress about this. Exams, we talked about these a little bit. 3 midterms, 1 final. So 4 tests altogether. The midterms are going to be in Canvas, and they're going to be proctored using HonorLock. If you haven't used HonorLock before, it's a Chrome extension. So you have to be using the web browser Chrome, and you have to download the HonorLock extension. It's a Chrome extension that allows a remote proctor to view both your webcam and what's going on your screen while you're taking the test. So think of it like any other test proctor, except, you know, is in Texas or something. The final exam is also going to be in Canvas, proctored by HonorLock, and the midterms are going to be during normal class time. So on the day of exam 1, whatever day that is, instead of coming to our Zoom meeting during class time, you will go to the exam in Canvas during class time. I'll probably build in a 30-minute window on either side in case you have technical problems, computer issues, anything like that. But because this is a virtual hybrid class, the tests have to be done during our regular class hours. Little recording notice. So again, COVID madness has us doing everything online. So I'm recording this. What's going on right now is being recorded on my computer as we speak. So just be aware, if you have your video feed on, there's a chance that you will appear in that recording. Those recordings will be posted to YouTube and they will be public. So if that's something you're uncomfortable with, you might consider paying attention to when your video feed is on and when it is not, and just be a little bit wary of your situation. These dates, each of these, I would put in your calendar immediately. So of course today, classes begin, we all know that. The last day to drop with a refund, the last day to get out of here and get your money back is this Friday. So if you decide, you know, I don't want to take this class right now, or I really hate online classes, or fuck this professor, or whatever, for whatever reason you don't want to do it, that's okay. Last day to get your money back and not have anything on your transcript is this Friday. So you got to make that decision by then. And then we do have a few holidays. We've got Labor Day and Veterans Day. Both of those fall on class days this semester, so we will not have class on those days. And then Halloween is the last day to get a W. So if you're thinking like, oh, I'm not sure if I want to withdraw or not, I'm not sure if I want to stay in, you got to make that decision by Halloween. If you stay in the class past 10/31, then you will be getting an A through F letter grade. Thanksgiving, college will be closing for the Thanksgiving holiday. I think the 26th is probably the Wednesday, but it might just be Thursday, yeah. So we will have class on the 25th, the Wednesday before Thanksgiving, but we will not have class on the Friday of that week. And then the last day of class is December 4th. The final exam is Monday, December 7th from 1 to 3 p.m. And then you'll see your grades posted, final grades posted online by the 13th. The grade breakdown is like this. About 8% comes from the homework, that's 45 points. About 13% comes from the study guides. And these are not graded so much for correctness as they are for completeness and clarity. So even if you make mistakes, you'll still get full credit on these as long as you're doing them and solving all the problems to the best of your ability. So it's a free 13% just to write out your solutions and submit them on Canvas. Please don't miss those. Midterms, so the regular tests, there's 3 of them. They're each worth 100 points, or about 53% of the grade cumulatively. And then the final is worth a little bit more than a quarter of the grade overall. So that is the breakdown, and you can see how the points are distributed down here if you want. The grade scale is the normal one, 90 to 100's an A, and so on. The next page of the syllabus here is pretty general boilerplate stuff. The GELOs, General Education Learning Outcome. These are some statistics that we measure to see how well students are doing on particular topics. Doesn't have anything to do with your transcript, doesn't have anything to do with your grades. It's just a statistic that the state likes us to track. So you don't need to stress about this, but if you're curious about what they are, you can click the link. And we have a little explanation here. Academic integrity, this is a big one, especially right now because of the online setting. I know it's more tempting than usual to seek outside help, to cut corners, to show work that's not necessarily your own. This is something I'm super sensitive about. I don't have any patience for it. I try to be very understanding. But if on a graded assignment, I see work that is not your own, or work that I suspect is not your own, then I don't have any qualms about starting a conduct trial. I hate doing those, but inevitably it happens, you know, a couple times a year, a few times a year, where there's some obvious, you know, shenanigans, and I have to do something about it. This is the only way we can keep the value of your degrees up. You know, if we let all the bullshit slide, then the value of your degree becomes less and less over time because people can't be confident that you've actually learned the stuff. So I'll just say this, show me what you actually know. If you're honest with me about what you actually know and you're candid with me and you want to learn this shit, we will find a way to get you through it. We can make it happen. So just be honest and be direct with me. I can be very understanding and very patient. I would much rather assign an incomplete and give you a little bit of time at the end of the semester to wrap things up than have to give you a ZF for cheating on something because you panicked and we weren't communicating. So please don't panic, don't cheat, just communicate and we'll work through shit. But know that these are the rules. You should be aware of what the rules are. So, so you know how you're being potentially judged. And just please be honest with me. The ADA stuff, so if you have a disability, if you're registered with the DRC, or if you anticipate registering with the DRC, or you have testing accommodations for any other reason, please let me know. So the DRC has sent me testing contracts for some folks, but I can't even fill those out until I speak with you a little bit about what it is that you need and how you want things to run, especially with everything being online. The opportunities for meeting those accommodations are a little bit more complicated because you can't physically go to the DRC, I don't think right now. So you have to decide whether you still want to use Honor Lock and just have me put in the accommodations through Canvas, or whether you'd like to work with Zoom and the DRC. It's all up to you guys. So please, if you do have anything like that through the DRC, or if you are looking like to register with them, but you haven't yet, and you're anticipating it, anything like that, reach out to them, but also reach out to me and let me know what's going on. Accessibility is pretty much the same thing. If there's any reason why you have a hard time reading the documents or hearing the audio or inputting the commands or anything like that, any issues with accessibility, talk to me, talk to the DRC. All my materials are put together in the markup language LaTeX, which means that they are friendly to screen readers and other things like that. But there might be a few little tweaks I need to make. So if there's anything like that, just let me know. And of course, let the DRC know, and we'll work together to make sure everything is as smooth as possible. Discrimination and harassment, I shouldn't have to say this, but don't be an asshole. Just be decent to each other, to me, to staff, everybody. Just be kind. The rules are here, and you might want to check them out just so you know exactly what is kosher and what is not, but this should not be complicated. Just don't be an asshole. I don't think we'll have problems with that. Student rights and responsibilities, this is kind of connected to the academic integrity stuff. Read the rules. Right, read the academic integrity and student rights and responsibility links to make sure you know how the college could potentially judge you if an issue were to arise. It's good to know how you're being judged. Even if there's not an issue, even if you don't expect an issue, it's good to know. And then the next bit here is a calendar. So this is a rough outline of what material we're going to cover when. For example, this week, we're going to do a little bit of algebra review. Now we're going to talk about the first few sections of chapter 2, which discuss tangent lines and velocities, limits. We'll throw in a little talk about the real number line and open intervals and those sort of basics. Next week, we're going to go full hog into limits. We're going to look at that rigorous definition of continuity, so what it means for a function to be continuous, not in terms of a picture, not in terms of intuition, but in terms of strict, rigorous mathematics. And then we'll talk about limits at infinity, which are kind of like horizontal asymptotes, and we'll just be plowing through this list pretty much at this pace. I might change things around a little bit. This is definitely a rough outline, so I would not try to don't think of this as a Bible, think of this as a basic outline. It may change. Anything else in here? So I got the date of the final down here at the end. I don't think there's anything else in the syllabus here. So before I close this, did you guys have any questions for me from the syllabus? Everybody comfy cozy?
Yes.
All right. So the next thing we need to talk about are some office hours. Basically right now, here's the plan. So I've talked, you guys are the third class I've had today, and right now I'm planning to do an office hour somewhere in the 3 to 5 block on Mondays. Somewhere in the 12 to 2, right now I'm planning 12 to 1 on Tuesdays. And then again, somewhere in the 3 to 5 block, probably 3:30 to 4:30 on Wednesdays. 12 to 1 on Thursdays, and a 2 to 3 on Fridays. I have one student who requested this because he couldn't make any of the others. I might add that in as a permanent office hour, I might not. But my question to you guys is, looking at this table, is there anybody who could not make at least one of these per week? So is there anybody that is not available during any of these bright yellow office hours? Anybody for whom not
Me.
of those work? Okay.
Sorry, I could never make any of those. I actually work full time and I'm actually taking off for the classes that I'm in.
Okay.
So I work 9 to 6 every day.
9.
But I'm very flexible and I can make time if need be.
Mm-hmm. Okay. And then Alyssa's saying the same thing, right? So then I'll ask you guys, and anybody else who hasn't spoken up, if none of the bright yellow office hours work for you, go ahead and in chat, let me know 2 or 3 that would work for you. So whatever it is, it could be a late evening or an early morning, just let me know like 2 or 3 hours per week that could work for you. I'll take the intersection of those and we'll find some schedule that ensures everybody can get at least one regularly. Like I could add an 8 a.m. on Tuesdays, or something like that. Right. And then the other thing is that of course, I can do these by appointment also. So if you can't make it to one of the regular scheduled office hours, you can always send me a message and we can coordinate a one-on-one meeting. But I like the idea of everybody being able to come to at least one of the regular office hours. So I can add a tentative here. Eight to 9, maybe Thursdays after 3 would work. Okay. All right, so then I'll think of it like this for now. Probably I'll end up going with this guy and this guy, and then the 4 bright yellow ones, but I still have one more group to meet with and I'll do a little bit more filtering. And after we have that all sorted out, I will update the syllabus page on Canvas with the precise office hours. But remember, even if these do not work for you, you can always, if you want to meet outside of them, just send me an email or a Canvas message and we can schedule a separate office hour. Okay, so those will be nailed down for sure by the end of this week. Then, let's see, we talk about the textbook, where to get cheap textbooks. So the PDF is great, I love the PDF. You will have access to an ebook through WebAssign. I'll show you what that looks like. Here's you guys. So the ebook here looks like this. I think a lot of it is in Flash, or maybe they're updating it to HTML5, but it loads slowly and it's got so much embedded garbage that I'm not a big fan of it. But it is the textbook, you know, it is. So this is okay, and if you're okay with this, this works. But if you would prefer the PDF, let me know. If you'd like a hard copy, I suggest looking at abebooks.com. This has been the place I found has the cheapest textbooks. Some of these are like special editions for certain colleges. I would stay away from those, but paperbacks and international editions are fine, like this. This would be okay for this class. It doesn't have the stuff you'd need for Calc 3 because it's just single variable, but it does have everything you would need for Calc 1 and Calc 2. And then you can find like the full banana here, a little over $100. It's not cheap, but it's definitely cheaper than the $300 they want at the bookstore. So yeah, shop around. abebooks.com is my recommendation if you're looking for a cheap physical copy. Otherwise, I would Google around for PDFs, or if you're satisfied with the MindTap thing that WebAssign offers, that works too. Harris, I can't quite do that because the PDF isn't 100% kosher, meaning like I don't want to be implicated in any sort of not 100% legal things. But if you send me an email, I can find a way to get the PDF to you. So if that's what you would like, just go ahead and reach out to me through Canvas or email. All right. Any other questions about these basic things here? Anything from the syllabus, or anybody never used WebAssign before, or anticipating problems, or have questions about how to get into WebAssign and how to get registered for our class?
No.
Well, feel pretty good. Any questions on the book? Matthew's never used WebAssign. Second edition Word. So 2 questions in chat there. To Matthew's question, if you haven't used WebAssign, it's pretty straightforward to use. So you won't have a sign-in because you won't have an account, right? So you won't have any account credentials you can put in. So if you haven't used it before, just go right here to enter class key. And this is where you want to put in the information from the syllabus. So this would go in the first block, and then these 2 in the remaining blocks. And that will go ahead and enroll you. It'll ask you for an access code. And if you already have your access code, which you can buy at the bookstore or elsewhere, then you can put that in. If you do not have the access code, then just scroll down a little further and you'll see an option to start the trial period, or the free trial, or whatever they call it, temporary access. Just make sure you get an access code before the trial period ends, which I believe is in 2 weeks. So yeah, in answer to Helly's question, you can buy a code at the SF bookstore. You can also buy them online. There's lots of places to get them. I don't know the cheapest place to get a WebAssign access code right now. Has anybody found a fairly cheap WebAssign access code? Sometimes they're cheaper on Amazon. Sometimes they're cheaper at the bookstore. And then in answer to Joshua's question, a second edition of the book would be okay, as long as you're not expecting like problem numbers to match up, and some sections might be numbered differently. Yeah, honestly, I have a few old editions of Stewart, and the variation between the 8th edition and the 7th edition is like nothing, you know, just a few different pictures and stuff. I think you can buy the access code direct through WebAssign. And yeah, an older version of the book is fine for reference. If you wanted to look up examples, look up theorems, stuff like that, that's fine. But just don't expect everything to match up exactly. You know, maybe section 5.5 becomes section 5.3 or something in the old edition, you never know. But as long as you're willing to pay close attention, then yeah, an old edition is fine. So in the chat, they were asking about buying the code direct through WebAssign. Yeah, I think you can buy the code straight from Cengage, and that might be the cheapest way to do it, but I'm not sure. So if you haven't bought your access code yet, I would recommend doing a little bit of research and seeing where the cheapest place to get one is. Oh, another good idea. I don't know if anybody has done it, but a GroupMe or a Discord or something like that for this class would probably be a really good idea. That way you guys can chat in a setting where you can be comfortable and it's not supervised, and you can share information. Just make sure you keep it ethical and reasonable. It'd be a good place to talk about like where to find the cheapest WebAssign access code. All right. I think that covers most of the sort of bookkeepy stuff. So I would like to start in on a little bit of math. Since this is Calc 1, really the place to begin is the real numbers. So officially, we start in section 2.1, but we're going to do a little primer. On the real numbers. For the most part, in algebra classes, you're just told that the real numbers are like this line, And it's got all the whole numbers, it's got all the fractions, and then it's also got a bunch of weird things, rational numbers, whatever. And that's true, but it's a little bit soft. So if we want to be really particular about what the real numbers are, you can say that the real numbers are all possible distances measured both positive and negative. They can be arranged on a line. With values ascending to the right. So this is what we'd think of as the real line, the normal real line. Maybe 0 is here, something like that. And maybe 1 is here. The square root of 2 is probably somewhere right around here. Pi is somewhere around here. And the big deal is that there are no gaps. The big difference between the real numbers and the set of all fractions, which is called the rational numbers, is that the set of rational numbers has gaps in it. For example, the square root of 2 is an irrational number. So if on your line you only had rational numbers, there would be a gap right here where the square root of 2 should be. It's an infinitely narrow gap, but it would still be a gap. So the big deal about the real line not having any gaps is what we say is it's called a complete set, or it's called the completeness theorem, that the reals are a complete ordered field. We talk a lot about intervals. In particular, open intervals are very important. So the open interval from A to B is the set of all numbers strictly between A and B. And this can be a slightly funny concept, but thinking about open intervals is a great way to start thinking about limits. So I'd like to look at a couple little examples of open intervals. So EG stands for exemplis grati, or gratis, depending on how you pronounce your Latin. For example, the open interval from 0 to 2 contains all numbers which are bigger than 0 and smaller than 2. So one of the questions I like to ask my algebra students at this point is, how many numbers are in that interval? And a lot of the college algebra students would want to say, well, there's one number in that interval, just one. One is bigger than 0 and one is smaller than 2, and there are no other numbers between 0 and 2 except for 1. But of course that's not correct because you know 1/2 is in there, 3/4 is in there, 1/pi is in there. There's all sorts of weird shit in there. There's infinitely many numbers in here. Sure, like 1 is in there, but 1/2 is in there, 1/3 is in there, 1/4 is in there, 1/5 is in there. All of those guys are in there, but so is like the square root of 2 is in there. So is 1 over the square root of 2. So is 1/pi. You know, 3/4, lots of things. Some of them are nice fractions made up of whole numbers like these. Some of them are irrational or fractions made up of irrationals like these. But there's definitely infinitely many numbers in the interval, open interval 0 to 2. And then another fun question to ask is, what's the smallest number in the open interval 0, 2? And this might appear to have a nice straightforward answer until you think about it a little bit more carefully. So is 0 in the open interval 0 to 2? Nah, it's not, right? So 0 is not in there. To be in this interval, you have to be both bigger than 0 and smaller than 2. 0 is not bigger than 0 in the same way that I'm not taller than myself. So you might start trying to come up with candidates. Well, is it 1? No, because 1/2 is smaller than 1 and in the interval. Well, maybe it's 1/2 then. Is 1/2 the smallest number in there? Well, no. Because 1/4 is in there and he's smaller. And you could see where this could go. You could then say, oh, maybe it's 1/4. But then no. Because for example, 1/5 or 1/16 or whatever, that's smaller. And also in the interval 0, 2. And so if you carry on with this sort of thinking, what you realize is that this interval doesn't have a smallest number. There is no smallest element in that set. You can get as close as you want to 0. But no matter how close you are, 0 is right here, 2 is right here. No matter how close you are to 0, whatever you think your smallest element might be, there's always somebody halfway between that guy and 0. So the basic concept of an open interval is that you can sneak up on one of the endpoints and stay within the interval. You can get really, really, really close to 0 and stay within the interval 0 to 2. But you can't get to 0 itself. 0 itself is not in the open interval 0 to 2. So this set has no smallest element. And similarly, there's no largest element. And this concept of getting really, 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 really close to something but not actually getting to that thing, that's the fundamental concept underneath limits. And so this is something that we want to internalize before we actually get to talking about limits of functions. So there is no smallest element because you can always get a little bit smaller. You can always get a little bit closer to 0. And similarly, there is no largest number. In the interval 0 to 2. However, you can get, and the word here is arbitrarily, close to 0 or 2 within the interval 0, 2. So while there is no largest or smallest guy in the interval, you can get as close as you want to the left end point, like 0.00000000001. That's a number that's in this interval, and it's real close to 0. But you could get even closer to 0. 0.00000000001 would be closer to 0 and still be within that interval. So this idea of sneaking up on something, getting real close to a number, but not actually getting to that number, is the fundamental concept underneath limits. And that's our first main topic for this class. So we need to be comfy with the idea of an open interval. I know everybody has seen this stuff before. I don't want to bore you too much. But if you're curious about where these concepts come from and why they're important, you might want to consider come here. So for more, Google least upper bound or greatest lower bound. Right, least upper bound are sometimes called suprema. Greatest lower bound are sometimes called infima. And in a slightly more grown-up math class like advanced calc or real analysis, we would begin by talking about those things. But here we're more focused on just getting the skills and being able to solve problems. So the theory doesn't matter. If you're curious about where this stuff comes from, that's the place to go. Next, we need to talk about closed intervals. So again, I know you've heard this before. I don't want to bore you too much. The closed interval from A to B is the set. You take the open interval from A to B and you union it with the set containing just A and B. In other words, this is the set of all numbers x such that A is less than or equal to x is less than or equal to B. It's the thing you're used to writing with closed brackets like this. You take the open interval from A to B, and then you throw in the endpoints. That's all. Now we can think of this as the open interval AB together with its endpoints. Another way I like to talk about this is that you can think of, picture a box, right? Like a cardboard three-dimensional box. An open interval is like the air inside the box. The closed interval is the air inside the box together with the box itself. So the open interval joined together with its boundary, which are just these two numbers, these endpoints, that's what constitutes the closed interval. And open and closed are not necessarily opposites of each other. It's possible to be both closed and open. But those are subtleties of topology that again, don't really matter too much in calculus. Okay, so I think that's probably enough on these. Of course, closed intervals, these do have a largest and smallest element. Namely, B is the largest, and A is the smallest. So open intervals are kind of interesting for us because they give us a way to start thinking about limits. Closed intervals, in a sense, are a little bit more boring because they contain their boundary. All right. So I think the next place for us to go, as we're kind of priming ourselves for the content that we're going to look at, is this idea of an average speed. So we're going to start on section 2.1, which is secants and tangents, particularly secant and tangent lines, and the concept of velocity. So for those who haven't seen this before, if you have some function f of x, here's the x-axis, this will be the graph y equals f of x, and you want to focus your attention on some interval, say from a here to b here. This point is b comma what? So I know the x coordinate here is b. What's the y coordinate there? If this is the graph y equals f of x.
F of b.
Yeah, perfect, f of b. Every point on the graph is made up of something comma f of that very same thing. And so this point over here is a comma f of a. And the line that joins these 2 points is called a secant line. And there is a connection between this secant line and the secant function that you learned about in your trig class. So I'll say maybe the line joining a comma f of a to b comma f of b is called the secant line for f of x from x equals a to x equals b. And the place where you've seen this before is when you talked about rates of change in your algebra class. You know that the average rate of change for the function f of x from a to b is the slope of this line. So that's an important definition. Let's go ahead and write that down. And it's not so much the formula that I want you to be worrying about here, it's the picture. Because what we're going to do is we're going to very slowly start dragging this point over to this point. And we're going to talk about the connection between secants and tangents. So make sure the picture is in your note, and then this definition, the average rate of change for a function f of x from x equals a to x equals b is the slope of the secant line. And then that's specifically, that's f of b minus f of a over b minus a. And of course, this is function notation. You can't factor in f or cancel b minus a's or anything like that. Okay. If your function happens to represent the position of a particle or a moving object, the rate of change of position has a special name. We call that velocity. Sometimes we call it speed, but really speed is just how quick it's happening. Velocity tells you whether you're moving in one direction or another. So this is also called the average velocity, the average rate of change. It's also called the average velocity if the function f is measuring the location, or sometimes called displacement, of an object. Okay. So what I would like you to imagine for a second is that I'm standing somewhere up high, maybe on top of a balcony or something, and I drop like a ball or a book. I drop it from a 20-foot tall balcony. So this is an example. It's not going to be a lot of hard calculation here, but I just want to try and give you some intuition for these things we've just defined. That ball is going to fall. But what's the graph of its height going to look like? Let h of t be the height t seconds after I drop it. So h of t is the height of the ball t seconds after I drop the ball. What is the shape of h of t going to look like? Well, I know at t equals, here's my t-axis. This is the graph y equals h of t. I know that when t is 0, the ball is up here, 20 feet tall, 20 feet in the air. And I know if I look a little bit later, the ball will have fallen, so its height will have come down. If I look a little bit later, the ball will have fallen more. And if I look a little bit later still, the ball will be on the ground, maybe here. Let me draw this so it's not linear. Let me resketch this graph, sorry. I want to do a little bit more exciting a graph for you guys. Make it a little more realistic. So when t is 0, we're up here at 20 feet. And maybe a second or so later, we're like here. Then if I look another second or so later, it should be like way down here. So the shape of this graph is actually going to be parabolic. Let's do it like this. All right, so we'll call this 1 second, we'll call this 2 seconds, why not? If I wanted to find the average velocity of this ball, if I wanted to find out how fast it's falling, I could look at the slope of the secant line from here to here. And that would tell me on average how fast the ball was falling from 0 seconds to 1 second. If I wanted to know how fast was this ball falling over its whole journey, I would find the slope of the secant line from the starting point to the point where it hit the ground. But what we would like to get at in this class, our goal is to get to a place where we can find not the slope of the secant, but the slope of the tangent. Should look something like this guy. So while the secant slopes of the secant line is the average velocity, how would we find the actual or instantaneous velocity? That's the big question for the first part of this class. So we can take average velocities, which are like slopes of secant lines, like the slope of this dotted line. But you know that the ball started out not falling at all. It started out at rest. And you know it's going much faster at this point than it was on average over that whole interval. How do we find out how fast the ball is falling at any particular moment in time? That's our goal. And the trick is to think about secant lines over smaller and smaller intervals. In effect, what we're going to do is take a limit as the width of the interval goes to 0. But we're a ways out from doing that. Right now, we just want to build some intuition. So let me grab a few concrete problems out of your textbook that we can look at. Well, how are we doing on time? 12:30 to 1:45. Barely enough time to look at one. All right. So you see these pictures are a little bit tricky to draw comparing tangents and secants, and I apologize for my bad art. But here the red line is the tangent line and the blue line is the secant line. And you see that their slopes aren't quite the same. This red line just barely kisses the function at that point. And it's coming in at just the right shape, at just the right slope to match the function really well as long as you stay close to that point. And you can imagine on this blue line, dragging this dot closer and closer to P. As I drag the dot here at Q closer and closer to the dot here at P, this blue line will look more and more and more like that red line. So what we can do, let's see, where do we find a nice concrete problem? No. Yeah. So here we go. We can use this. The ball is dropped from the upper observation deck of the CN Tower in Toronto, 450 meters above the ground. Find the velocity after 5 seconds. And they give us the height here. They say the displacement. So let's make this nice and concrete. It's 4.9 t squared. So a ball is dropped from the top of, what do they say, 450 feet? 450 meters. Find the velocity, I say, find the velocity after 5 seconds. So what we need, after t seconds, so if the distance fallen after t seconds is s of t, measured in meters, then Galileo says that this guy should be 4.9 times t squared. Right. So s of t, this is the distance fallen should be 4.9 times t squared. This comes from experimental work done by Galileo. Later we'll talk about what Newton did to make this experimental approximation exact. So how do I find the velocity? The velocity, on average, after 5 seconds is equal to the average rate of change. For s of t. From t equals 0, the moment I drop the ball, to t equals 5. And that average rate of change is s of 5 minus s of 0 over 5 minus 0. It's the slope of the secant line. Maybe I'll give my s's these little tails so you can tell that they're s's and not 5s. S of 5 is 4.9 times 5 squared. S of 0 is 4.9 times 0 squared. And 5 minus 0 is just 5. So the numerator there is 4.9 times 25. And the denominator is just 5. And you can cancel 5 into the 25. And you get just 4.9 times 5. So, you know, somewhere in the neighborhood of 25 meters per second. But that's the average velocity. How could I find the exact velocity? That's the thing that we want to have in our heads as we move forwards. How do we go from this secant line? Well, I'll go ahead and graph this 4.9t squared, and we'll see what we found and how it compares. They're not looking at the height right now, they're looking at the distance the ball has fallen. So rather than being a parabola opening down, this one's going to look like a parabola opening up. The graph s of t equals 4.9t looks like this. And maybe here is t equals 5. Over here is t equals 0. So what we just calculated is this guy, the slope of that secant line. It's equal to the average rate of change. And that we found to be 4.9 times 5. But the velocity of the ball at that moment is not this average rate of change. It's not that secant line. It would be, what the hell? My document camera just crashed on me. Why? Serious? All right, I'm gonna add one more thing to this picture and then I'll let you guys go. I know we're going a little bit over time. I appreciate your patience. Hurry up, QCam. All right. So the thing we just calculated is the slope of this secant line. About 25. The thing we want, the instantaneous velocity, the velocity at that moment, is this tangent line's slope. So the instantaneous velocity, the slope of the tangent, is the actual or instantaneous velocity. What can we say about that? Well, we can say it's probably bigger, right? You can use a geometry argument to say that the slope of the bold line here has to be bigger than the slope of the dotted line. So we know that this is going to be bigger than 4.9.5 or a little bit bigger than 25-ish. And one way you can calculate that is by imagining moving this point closer and closer and closer and closer to this point. The first few homework problems you have are going to ask you to approximate the slope of this line by calculating a bunch of these things. By doing a bunch of these calculations, only instead of using 5 and 0, you might use 5 and 1, 5 and 2, 5 and 4, 5 and 4.5, 5 and 4.9, 5 and 4.99. So you can creep up on the slope of the bold guy by calculating a bunch of these dashed guys, bringing this left point closer and closer to this right point. And that bringing closer and closer is precisely the concept of a limit. So I'm going to give you guys a few problems like this, where you calculate average rates of change, a few successive average rates of change to approximate an instantaneous rate of change. And then we're going to talk about limits. We'll have a little detour to talking about limits and how to take limits, limits of functions, graphing functions a little bit. And then we're going to return to this problem of velocities and tangents and see how to use limits explicitly within them. Okay, I think that's enough for day one. So I'm going to go ahead and end the recording here. Are there any last minute questions about the definitions or examples that we looked at today, or any of the sort of bookkeepy stuff? Anything along those lines? So maybe for the sake of your notes, let me come back here real quick. I need to turn the screen share back on. Before you go, so to approximate the slope of the tangent, try calculating S of 5 minus, let's bring this point over here to like 4. Over 5 minus 4. And then maybe S of 5 minus S of 4.5 over 5 minus 4.5. And then S of 5 maybe minus S of 4.9 over 5 minus 4.9. So what you would be doing there is bringing this point closer and closer and closer to this point. So your dotted line will start to look more and more and more like that tangent line. So next time I'll do some calculations like this for you guys. And also we will look at some graphs and how we can connect secants to tangents and a few more application settings. But then we're going to move on to talking about limits. There's a bunch of limit rules and notations, laws, things we have to learn before we can treat these things formally. So that's where we're going. And I think this is a sound place to leave it off for today. So I'll go ahead and actually stop the recording here.